So problem 1, you got the space in the left of each diagram, the force diagram for block B, to the right, a force diagram for block A. Which of these should we draw a force diagram for first, B or A? We're going to draw B first. Now, before we do that, we want to consider what kind of motion it's experiencing. And what kind of motion does it have?
Constant velocity.
Which tells us the acceleration is 0, which means the net force is 0. And specifically, we're talking about along the x-axis this time, right? Specifically, we need to make sure the net force along the x-axis is 0. So, let's go ahead and draw a force diagram for block B. Anybody have any suggestions? Give me one.
So you go up, you go down.
One force.
What do you mean suggestion? Oh, force gravity.
Great.
By the. Okay.
Force of gravity on B by
E. By
great.
Earth.
Somebody else. Anybody know upward force?
Force normal on B by the table.
Bigger, smaller, or same?
Same.
Force normal on B. Are you okay if I use by the surface?
Yeah.
Are they the same size?
Yeah.
Excellent. A horizontal force.
To the left. Force of push on B by A.
You're saying that A is pushing B to the left. Does that make sense?
Yeah.
We also say force normal.
Force normal on B by A. And Cole, why did you want to say, hey, that's a normal force?
Because they're both surface.
It's a flat surface, boom, push it, perpendicular to the surface, we're all good. And then if B is moving at a constant velocity to the left, what else must exist?
Friction.
Friction
To the,
to the right.
how bigger, smaller, same?
Same.
Same size. So I'll double hash mark those. We got force of friction on B by the surface. Do these forces take care of the expectations that it's not accelerating and there's no net force? Can you think of any other forces that are acting on block B? Could anybody tell me which of these 4 forces shows the interaction between block A and block B? Justin. The one going up, down, right, or left? The one going to the left. Force normal on B by A, right? And if there's a normal force on B by A going to the left, what do we know has to be happening to block A? There has to be a on A by, excellent. All right, so we're good over here. Let's transfer over to A. Define our system as A. Look at the mass of block A compared to block B. What's going to be different for A than B? We have double the mass, which means what has to be double? Double the weight. What kind of force? Force of gravity has to be bigger, right? It's supposed to be twice as big. I don't know if I might have made that obnoxiously large. Let's see here. 1, 2, that looks like it's about right. So we got force of gravity on A by the Earth, and the upward force? Excellent. Force normal on A by the surface, and we'll triple hash mark those to say, hey, these are the same size. We know that all of this is how things push and pull on one another. Sophie already told us if there's a normal force on B by A from the blue force diagram, then on the red force diagram, we have to have a force normal on A by B. Which direction does that have to go? To the right. So I have to measure that force normal going to the left on that force diagram and bring it over here to our red force diagram for object A. Force normal on A by B. And we had 2 hash marks over there. We want to say, hey, these have to be the same size. Now, A is moving to the left. What other forces have to be acting on it?
Force of push on A by N.
Which way would that be going, Michael?
To the left.
To the left. Is anything else pushing on A to the right? Friction. Bigger, smaller, or the same as the friction on B? Have we studied friction, really? Like, have we ever measured friction? Not so much. So How about this? Why don't we make it either the same, or since it's more massive, we could make it a touch larger. Are you cool with that? Force of friction on A by the surface. Now, Michael had already brought up that there has to be a force of push on A by the hand, going to the left. The next question becomes, how long does that force have to be for all of this predetermined stuff to be true? Josh?
Be twice as long. But he said, well, force of friction on a surface by plus force of normal A by B combined together to make force of push on A by hand.
So what I'm hearing is you want me to take the force of friction on A by the surface, the length of that, plus the force of normal on A by B, and add them together
Yeah.
and extend it out to the other side. So I'm going to go ahead and measure. Force of friction is this long. I'm going to add to that the force normal on A by B, which is this long, and you're telling me it has to be longer than that or the same size as the sum of those two?
Wait, same size.
Same size, because the net force has to be zero. Could somebody who hasn't called one out yet tell me which of the forces on this red force diagram shows the interaction of object A and object B? Jack? Those are our Newton's third law pairs. Those two forces that I've underlined in green show the interactions between these objects. Now there's one other thing that we were required to do for this problem. It says in the space to the left for each diagram, oh, nope, that's not it, right above there. The choices for the questions are as follows. Did block A exert the greater force on B? Did B exert a greater force on A? Or are the forces equal? And you would say they equal. So make sure we put a letter C on there, and we can put that one to bed. So I'm going to pull off of here, click on there,